All right, section 9.1 is about trig identities. Trig identities are important, and we're going to use them in here, and you'll see them a good bit in calculus, especially if you take calculus 2. So first up, what is an identity? Well, an identity is a type of equation. And what's the difference in an equation and an identity? Well, an identity is true for any value you plug in for the variable. So the examples I've got here, like 2x plus 2x equals 4x. That's true regardless of what x is, so it's an identity. This over here, 4x plus 3 equals 7x minus 5, that has a particular solution. It's only true for one particular value of x. So that's sometimes called a conditional equation, but it's just an equation. An identity has the property that anything you plug in for the variable, it's true. So there are a bunch of trig identities here. I took this list straight out of the book. And really, you should either memorize this entire table or at least memorize enough of it so that you can generate the rest of it. Now let's look through it. I want to tell you which ones of these that I know by heart and which ones I have to work out. Let's see this first one. This is one you should know. Cosine squared plus sine squared equals 1. These are Pythagorean identities, and that one comes from the unit circle. When you have your unit circle here, this is cosine theta, sine theta. Those are the coordinates there. And let me make this bigger so we can see it. Remember, that makes the y, this is sine, and this here, x, is cosine. And so this is 1. And so this comes straight from the Pythagorean theorem on this little right triangle. So definitely you should remember that one. I'm going to skip down here to these reciprocal identities. You should know these. Really, this table is kind of redundant because if you know that sine is the reciprocal of cosecant, then you kind of get this one for free. Cosecant is the reciprocal of sine. And the way I tell people to remember these are with sine and cosecant, and cosine and secant. Both of these have an S and a C. So cosine and secant are reciprocals, and sine and cosecant are reciprocals. And then tan and cotan are reciprocals. If you know these, and you know this one, then you can generate these other two here, these two. Here's how you can do that. And I have to do this all the time because I never can remember which side the one goes on these two equations. But here's the cool thing. If you take cosine squared plus sine squared equals 1, if you take that and you divide it by cosine squared, well, look at what this gives you. Cosine squared over cosine squared is 1. Sine over cosine is tangent, so this is tan squared. And 1 over cosine squared is secant squared. So by doing that, we can generate this identity, which is this one here. And if you divide it by sine instead of cosine, it would generate this one. All right. What else do we have on here? Yeah, these down here you should memorize. Tangent is sine over cosine. And really, if you know that tangent is sine over cosine, and you know that cotangent is the reciprocal of tangent, then you've got this one. And these up here, these are also kind of important. It's just saying that tangent and sine are odd functions. And cosine is an even function. So I would say you need to memorize the ones that I've got in the purple boxes here. And the rest of them you can sort of generate from there. All right, so one of the things we're going to be doing here is using identities to simplify expressions. So let's start with this thing here. cosine squared minus 1 over cosine x. Now, looking at this, the first thing I would notice is this is cosine squared x minus 1. That's part of the Pythagorean identity, or at least you can get it from there. If we know sine squared plus cosine squared is 1, then cosine squared minus 1 is going to be, let's see, we can rearrange that. Cosine squared x minus 1 equals minus sine x, or sine squared x. Over cosine x. And now I can split this sine up here into a sine x and another sine x. It's over cosine x. So I can take two of these and put them together. Right, this is minus sine x tan x. So basically the two that are circled here become the tangent. Is that really simpler than the first thing? I think it is, because it's not a fraction and it doesn't have the cosine squared in it. But yeah, there's definitely an argument to be made there of, is this really simpler? I don't know. The important thing is you should be able to work out that this and this are equal to each other. All right, let's look at the next one. Cosine x times tan of negative x. All right, what I want to do is get rid of this negative x here. So if we come back up to these even-odd identities, tan of negative x is negative tan x. So what I can do is I can pull that negative out front. So I can rewrite this as cosine x times negative tan x. Now let's just pull the negative out front. All right, is there anything else I can do? Well, let's see, tangent is sine over cosine. So I could rewrite this as minus cosine x times sine x over cosine x. Now I can cancel and I wind up with just negative sine x. And that's definitely simpler than what we started with. All right. Okay, cosecant plus cosine times cotan of negative x. All right. First up, what can we do with this negative? Well, cotangent is an odd function. We saw that up here. Cotangent of, let's see, cotangent of theta is minus cotangent of theta. So that means you can take this negative and move it out front. So let's see, this is cosecant x minus cosine x cotan x. All right, can I do anything else to this? I think maybe so. Let's try rewriting it in terms of sines and cosines and see if anything will cancel out. Because let's see, cosecant, remember that's 1 over sine. And let's see, cosine, I'm just going to leave that as cosine. Well, I'm going to write it as cosine over 1. Then the cotangent is cosine over sine. I'm just going to put it together in a single big fraction there. All right, so we've got two fractions we can put together. The denominator is sine, and the top becomes 1 minus cosine squared. And let's see, what is 1 minus cosine squared? Well, from our Pythagorean identity, 1 minus cosine squared is sine squared. And we can cancel one of those and we're just left with sine x, which is definitely much simpler than the thing we started with. One thing I should mention here, I might have mentioned this before, but when we've got sine squared x like that, just to clarify, if you have sine squared x, that means that you take the sine of x, then you square that value. if you have sine of x squared, that means you take the x and square it first, and then you take the sine of that. All right, let's do a couple more. Secant x plus 1 times secant x minus 1. Okay, when you see this, the first thing I want to do to it is multiply it out. So it's nice because we've got a plus here and a minus here. So when you add this up or multiply it out, you get secant squared x minus 1. Now, yeah, you also get minus secant x and plus secant x, but those cancel away. So we're left with this. And this looks like one of those Pythagorean identities. Now, I could go back up and look at it, but I'm going to figure this out on my own here because I know sine squared plus cosine squared is 1. And let's see. My cat is running around like crazy in the background. I'm not sure if you can hear it, but that's what I'm laughing at. Okay, let's put this into, I want to get secant here. So secant is 1 over cosine. So I'm going to divide this whole thing by cosine squared. And the identity becomes, let's see, sine over cosine is tangent squared. Cosine over cosine gives you 1, and this gives you secant squared. So yeah, if I take this over here, this is sort of side work. So secant squared minus 1 is going to be tan squared. And that's as simple as we can get it. This stuff, it might seem silly right now, but when you get into calculus 2, this stuff is going to be useful. All right, let's see. This is the last example. We've got tan x plus cotan x over cosecant x. Now, if you got something like this that looks complicated, the best thing to do is probably just rewrite it in terms of sines and cosines. So let's see, tangent is sine over cosine. Cotangent is cosine over sine. And cosecant down here is 1 over 1 over sine. So we get this thing. Now what can we do? Probably what I would do is, I don't like this big double fraction. So let's rewrite this as sine x over cosine x plus cosine x over sine x. And actually, I'm gonna bring this down here, and I'm gonna leave some space, and I'm going to multiply this by sine x over 1. Basically, I'm taking this and I'm multiplying by the reciprocal of that. Now, I left all this space in here because I want to get the same numerator and denominator. Actually, no, I don't need to do that. Back this up over here. If I take this and I distribute that sine x across, let's see, what do I get? On the first one, I get sine squared x over cosine x. And on the second one, I get sine x, well, the sines cancel and I just get cosine x. Now, it would be nice if I had the same denominator here. So I'm going to multiply this over here by cosine x over itself. And what I wind up with is sine squared x over cosine x. Let's see, plus cosine squared x over cosine x. And now that sine squared plus cosine squared is 1 over cosine x. And that's just secant x. All right. So anyway, on these problems, probably what you want to do a lot of the time is rewrite things in terms of sines and cosines, use those Pythagorean identities, and if you have a negative, if you have sine of negative x or cosine of negative x or something, get rid of that immediately. So anyway, we'll stop here and we'll look at verifying identities in the next video.